Good morning, Algebra 2 students. Here is the second part or second video of factoring polynomials. Now, in the first video, we talked in great detail about the difference of cubes and sum of cubes. So I'm just going to review quickly what you do when you'll end up with one of the special ones, which is step 2. For example, this first one is difference of squares. These are both perfect squares. Difference, it's going to be 3x and 3x, 5 and 5. Difference of squares, different signs. And then taking it a step farther, if you're going to solve this, you set each of these equal to 0. And those would be your two solutions. This next one, you would recognize this is sum of, and these are cubes. So your first factor would be 2x, because 2x cubed would be 8x cubed, plus 3, because 3 cubed is 27. And then if you remember, you square this first term. You multiply the two together, which would be 6x. You square the last term, which will give you 9. And this needs to be negative, opposite of the first term. Now, if you were going to solve this, you would set each of these equal to 0. This is going to give you negative 3 over 2. And then this is a quadratic equation. So you would try to solve this by either factoring it or by using the quadratic formula. In this case, you'd probably need to use the quadratic formula. You will get solutions that involve I. The next one, hopefully you recognize, this is a perfect square trinomial, so it'd be 2x and 2x, 5 and 5, and both signs are negative, and we get one solution, which would be a positive 5 over 2. Next one is difference of cubes. Difference, these are two cubes, so it'd be 3x minus 2. And then you square this term, which gives you the 9x squared. You multiply the two together, which gives you 6x. And that needs to be positive, opposite that sign. And then your last term, you square the negative 2, and you get positive 4. If we were going to solve, my one solution would be a positive 2/3. This is a quadratic. I would need to try to factor it, which I don't think it will. Use the quadratic formula. So if you find your discriminant, it'd be 36 minus 4 times 9 times 4, which gives you, give me a second here, grabbing a calculator, and we would have 36 minus 144, which is a negative 108. That's the part under the square root sign. This would be a negative 6 all over 18. And then you need to simplify the negative 108, but obviously those would not be real solutions. All right, the next step is when you have 4 or more terms, grouping. And we did this before. This is when you were doing the method. But if you remember, we grouped these together. And for those two terms, I could take a 6m out, and that would leave you with n plus 3, which means I got to have n plus 3 here. That means I'm taking out a negative 1. So now my factor would be n plus 3 times what I have left, which is 6m minus 1. And I've got two variables here, so it would be harder to solve this because you don't have just one variable. But you could set those equal to 0 and then solve. Next example, here's one where we do have a greatest common factor. I could take a c out of everything. I'd have c cubed plus c squared minus c minus 1. And then I would do grouping. Oops. I'm going to keep this. That should just be my c. And then for these, I could take out a c squared, which would leave me with c plus 1. I need a c plus 1 here. That means I'm taking out a negative 1. And then it gets really fun. Now we're going to have c, bring that down. And then I'm going to have c plus 1. Taking that out, I'd be left with c squared minus 1. Which, it even gets more fun, that is difference of squares. And that would be c minus 1 and c plus 1. So my solutions would be c could be 0, negative 1, positive 1, and then also negative 1 again. Next one here, I've got 4 terms. I'm going to do grouping. I could take an x out here. I'd be left with x minus y. So I need to have x minus y here, which means I'm taking out a 2. And then I'd have x minus y times x plus 2. And again, we've got more than one variable, so we're really not going to solve that type equation. Big thing is to be able to factor it. All right, last type of problem is something that's in quadratic form, which means the form of a quadratic. This is a quadratic. This is second degree. And it will be in the form of that if this middle value of x, which is a power of 1, is half of the beginning power of 2. So if this would be x squared, this would have to be x to the 4th, and that would be in quadratic form. If this would be x to the 5th, then you'd have to have 10 here. So that first power is going to be double that middle second power. If it is in quadratic form, we're going to solve it the same way we have with quadratics, which would be by trial and error or by the method. For this one, it is quadratic form. By the method, I have y to the 4th. I would need to have y squared and y squared. And then I need a positive 4. The positive tells me both are negative. That's all the same. My factors would be 1 and 4. That works. But then I look at this and say, hey, this is difference of squares. It'd be y and y, 1 and 1, minus and plus. And this is difference of squares, so y minus 2 and y plus 2. Then my solutions would be positive 1, negative 1, positive 2, and negative 2. This next one here, you can see this power is double that power, so this is quadratic form. I could start out with m to the 3rd and m to the 3rd. Both signs are negative. I need factors of 64 that are going to give me a negative 16, which would be 8 and 8. And then this is difference of cubes. So I'm going to have m minus 2. And then I square the m. I multiply together, make it positive. I square the 2, which gives me 4. And then I'd have the same thing here, so I'd have another m minus 2 times m squared plus 2m plus 4. And if I'm solving this, I would set all of these equal to 0. That's going to give me m to be positive 2. And then I would need to solve this using the quadratic formula. I'd find my discriminant, 4 minus 4 times 1 times 4. 4 minus 16 is a negative 12. I'd use the rest of the formula. I could simplify that, but I know they're not going to be real solutions. So that's covering more in detail the grouping method and the quadratic form. Went kind of fast there, but the idea is for you to look through this, review it, rewind it, and watch it several times there.